This is Josh White with JW Math Tutoring. Do you find yourself running out of time on the math section of the ACT? Do you find yourself having to guess on maybe the last 10 or even 15 questions in the math section of the ACT just because you don't have time to look at those problems in detail? Well, if you answered yes to either of those questions, then this is the perfect video for you. I'm going to go through and show you how you can improve your timing on the math section of the ACT in order to be able to attempt more questions and hopefully attempt the entire section. Now, before we get to that, just make sure that if you like this video and my other math-related videos, to obviously give it a thumbs up. Also, click on the subscribe button to subscribe to my channel and sign up for notifications so that whenever I post a new math-related video, you'll find out immediately. And in addition to that, if you're looking for more practice work on the math section of the ACT, please check out my new Improve Your ACT Math Score course. It's currently live on Teachable. The cost is $100 and it includes over 10 hours of video instruction on over 80 math-related topics, including some of the strategies and techniques we're going to go over today, and very many calculator operations that you can also use on a graphing calculator to help you solve problems as well. Okay, so with that being said, let's go ahead and get started and see how you can improve your timing on the math section of the ACT.
But life is a dream that calculus could never predict.
As I mentioned previously, this video is going to show you how you can improve your timing on the math section of the ACT. So first, let's just talk a little bit about the math section on the ACT in general. So if you're watching this video, you probably already know by now that you have about 60 minutes to attempt 60 problems. So that comes out to 1 minute per question or per problem on average. But a lot of times, students find themselves, being unable to attempt all 60 questions and instead end up having to guess on multiple questions, basically because they ran out of time. Maybe it's the last 5 questions or 10 questions, or it could even be more. I mean, some of them, I've read situations where when a student first starts to prepare for the ACT, maybe they take a practice test and they only, end up being able to answer half of the questions. They only get to somewhere in the 30s before, essentially having to just fill in and guess. So if that's happening to you, basically, you need to improve your timing. So what we really mean by that is, you need to complete problems, in a quicker manner. You need to spend less time on, essentially each or most problems on the test. But how do you do that? That's basically, the fundamental question, and that's what we're going to look at right now. So, how do you spend less time on questions? One way to do that is to use techniques when you're answering and or solving questions. And some of these we're going to take a look at today are process of elimination and also the idea of backsolving. These techniques can save you a significant amount of time compared to solving problems the traditional way that you may have learned in a math class. And then another way that you can save time on questions is by using a graphing calculator. First, you can use it to do arithmetic calculations rather than trying to do them by hand or do them in your head. But the second way that you can save time is by using the specific operations that are built into your graphing calculator. And I'm going to demonstrate these on a TI-84 Plus C model to solve problems either in their entirety or to solve part of a problem. And another thing you need to keep in mind, and this is kind of related to the process of elimination technique, which we're going to go over, but you should only do as much as you need to answer the problem. You don't want to spend extra time or waste extra time on a problem, after you've already figured out what the correct answer is, or possibly if you've narrowed it down to 2 answer choices, then you could guess and have a 50-50 chance of getting it right as compared to, just a 20% chance just guessing without even looking at anything in the problem. So the main takeaway is, don't spend extra time on a question after you figured out the correct answer. Just mark that correct answer, fill it in on the answer sheet, and then move on to the next problem. So the first technique we're going to go ahead and talk about is process of elimination. So what does this mean? What does this entail? Basically, the whole idea is when you're attacking a question, a lot of times it's quicker and easier to try to go through and eliminate answers that you know are wrong or incorrect rather than trying to figure out which one of the 5 answers is the correct answer. It's basically a different way of thinking about answering problems. And the reason it's so important is because this is a multiple choice test. So you are given the correct answer to the problem. That's very different than most math tests that you would take in school, which might use like a fill in the blank type problem where you're just given a problem and then you have to come up with the answer and you're not provided any answer choices. Or, for example, on the SAT, where they have the grid ins at the end of both of the no calculator and the calculator section, where you have to figure out the answer to the problem and then fill it in. In other words, you're not given any answer choices. So process of elimination is the first technique we're going to talk about. And again, it's a different way of looking at or thinking about, finding the answer to the problem. And as I already mentioned, a lot of times it's much quicker than solving a problem the traditional way. Now we're going to take a look at an example problem. This is from the April 2022 test, Form E25, problem number 13. So the problem is on the screen there. Basically, they give you 2 lines, and they say when you graph those 2 lines out, at what point do they intersect? So it's basically asking for the solution to this problem. Now, if you're going to solve this the traditional way, or the way you learn to do it in class, then, if you follow their instructions, you would go ahead, you would graph out both lines, and then you would see where they intersect. Or you could also recognize this is a system of linear equations, and you could use substitution or elimination. And you could go ahead and solve it using that method. And you could find the value of x or y, and then plug that back in to find the value of the other variable. But if we use the idea of process of elimination on this, it is much quicker and much easier to figure out what the correct answer is going to be. So notice a couple things. First of all, in one of the equations, they tell us y is equal to x. So notice that, okay, y equals x. That means x and y have to be the same value. Go down through the answer choices. Notice, in answer choice A, are x and y the same value? No, eliminate it. In B, are they the same? No, eliminate it. In C, are they the same? No, eliminate it. In D, are they the same? Yes, could be the correct answer. In E, are they the same? No, they are not. Eliminate it. So therefore, I know right away it has to be letter D, 5, 5, because that's the only point that meets the criteria of even just the first line, much less the entire system. And notice, I did not have to set up a system of equations. I did not have to graph out, each line. I didn't actually have to solve and find the values of x and y. I just used the answer choices and went through and basically kind of eliminated them based on information given in the problem. Note you could also do this with the second answer choice, or not the second answer choice, excuse me, the second equation, the x plus y equals 10 here. In other words, you could have checked them against that equation. The only thing is, there are 3 possible answers that could work for the second one, which would be like letter choice B here, 0, 10, obviously 5, 5, and then also 10, 0. In other words, you still would have eliminated like A and C. So if you did that, you would have narrowed it down to 3 choices, and then you could have looked at it further, gone to the first equation or whatever. But the point or the key takeaway here is you don't need to solve the problem in a traditional manner. Instead, you can, in some problems, not all of them, but some, you can look at the answer choices, go through, and eliminate the wrong ones based on some specific condition or criteria in the problem, and then just be left with the right answer without having to do really any work. Now let's take a look at another problem where we can use process of elimination as part of solving this problem to get the answer. This is from excuse me, April 2022 test. It's Form Z08, the international version. It's problem number 46. And in this problem, if you go ahead and read it, basically you're given 3 points, A, B, and C, for a triangle. And then the triangle is translated both horizontally and vertically. So it ends up like being shifted in both directions. And then they ask for the vertices of the quadrant that the vertices of the new triangle or the image lie in after the translation. So here's how I would use process of elimination for this to save some time. Okay, so if you want to start with the first point here, A, negative 3, 3, and the actual work I'm doing here is kind of the traditional method that you would use to solve this, but I'll show you where the process of elimination comes in. So we've got negative 3, comma 3 as our starting point. And then the translation says we're adding 5 to x and we're subtracting 2 from y. Okay, so we do that, we get 2, comma 1. All right, so that's obviously in quadrant 1. So notice right away, we can eliminate this, we can eliminate this, and we can eliminate this. So at this point, if you were like really running out of time, you could at least now guess between two of them. But we don't need to spend a lot more. We don't need to spend a lot more time figuring out what the correct answer is. So now let's say we wanted to look at point B. However, notice I have the same x value here, coordinate value for points A and B. So I'm not going to bother checking that. I'm only going to check the y value and see, do I end up in quadrant 1 or quadrant 4? So when I do that, notice that the y coordinate, starts at positive 1, and when it goes down 2, it now goes to negative 1. And we already know the x coordinate is going to be the same. So notice 2, negative 1, that's just right down here. That's quadrant 4. I now know the answer. It's letter J, and that's it, and I can move on. So the key kind of elements here for process of elimination are, 1, you don't need to check the x-coordinate of point B because we already checked it. It's the same as point A, so don't spend time doing that. 2, eliminating some of the wrong answers after we checked the first point right away to kind of narrow it down to 2 possible answer choices. And then 3, the third thing is, once we did just the y-coordinate of point B, and we saw that it was quadrant 4, like we now know what the correct answer is. We know it's quadrant 1 and quadrant 4. We do not need to check point C. There's no point in wasting time doing that. We have our right answer. We move on to the next problem. Now, the next technique that I'm going to talk about, which can also save you time on problems, help improve your timing, is backsolving. So backsolving, or as it's also known, plugging in the answers, is again another technique, another strategy that you can use to solve problems rather than doing them the traditional way. To take a look at how we can do this, here's a problem from the April 22 test, form E25, and it's problem number 25. So in this situation, you're given a parallelogram. You're told what its perimeter is, and you're told one of its sides, and you're asked to determine the other 3 sides. So the traditional way you would solve this, say in a math class, if you weren't given answer choices, is you'd probably first draw a picture and label some sides of 18 and 18, and then the other sides you'd probably label x and x. And then you'd set up an equation to solve, and you'd sum it all up, and it'd equal 80. And then you'd combine like terms, move number terms over to the other side, and you'd solve it for x and get your correct answer. But we can just use these answer choices they've given us in order to figure out which one has to be correct. So, for example, And I'm just going to pull up my calculator on the screen now. And before I start adding the answer choices together, one thing to notice, one thing to be aware of, I'm going to use a little process of elimination here to help solve this. So here we have a parallelogram. Hopefully you know that a parallelogram has two pairs of opposite congruent sides, meaning the opposite sides have the same length as each other. Therefore, there's going to be like two sides that are 18 and the other two sides have to be the same number. So that means answer choice A is out right away because this would have three sides of 18 and one side of 26. And a parallelogram cannot be set up in that way. It'd have to be 18, 18, and then something else, something else. So now we have three possible answers to check. If none of them work, then we might choose E, but one of them probably should work. And notice I'm going to start in the middle with the 18, 22, 22. The reason being because if it's too high, I can eliminate that answer choice and I can eliminate answer choice D as well. So I can eliminate both C and D together, and then I know it pretty much know it would have to be B, although you could still add it up just to confirm. On the other hand, if it's too low, if when I add up these four sides I get a number less than 80, then you can eliminate B and C right away, and then we know it pretty much has to be D, or if we add it up and it doesn't work out, it could possibly be E. So I'm going to start, like I said, with answer choice C. So I'm just going to add up 18 plus 18 plus 22 plus 22. Okay. And so notice I actually do get 80, so that is the correct answer. And that's it. So I know there's a lot of talking, of me going through there and kind of explaining things and, talking about, that was really kind of like using process of elimination there to eliminate an answer choice and also explain which one I would start with. But the actual solving of the problem of just punching four numbers into your calculator and hitting enter takes, no time, less than 10 seconds. Even if you started with B and that didn't work and then went to C, it still wouldn't take very much time. And it should take you less time than actually, sketching out a picture, labeling 18, 18, X and X, and then setting up an equation, 18 plus X equals 80. And then going through and solving out that equation to see what the value of X is. In other words, what the other sides have to be. So again, that's the first example of how you can use the answer choices, back solving, to plug them in and solve a problem in a much quicker and more efficient manner to save time on the test compared to the traditional methods. All right, so now let's take a look at another example problem. This is again from an April 2022 test. It is from form Z08. It's problem number 40. And this is just basically an absolute value equation. So the traditional way you would solve this is you would technically set up two equations. So you have 1 minus 2x equals 3 and 1 minus 2x equals negative 3. And then you go ahead and you solve them each out and you get your two answers. However, we can solve this in a much quicker and easier manner by plugging in the answer choices and, in conjunction with that, using the graphing calculator. So when we go to check these answer choices, and this is another skill basically that you want to work on or that you want to practice, you need to look at and see which number do I want to plug in so that essentially I can eliminate as many answer choices as possible. So for example, if I plug in -1 and it works, then that means I've only eliminated one answer choice. Technically K would be gone because K does not have a -1 in it. Okay, so notice it's I'd split it into like 4 that work and 1 that don't. Obviously, if it doesn't work, then it would just basically be k by process of elimination. You wouldn't have to do any more work. However, then I would still have 4 choices left to check, and I would have to check 2 and 1 and -2, and if none of them worked, then it would be F by process of elimination or whatever, so it would take a little bit more time. However, notice if instead I go ahead and I first start with +2. The reason I want to check +2 first is because then I can kind of split it into like either 2 answer choices to check or 3, kind of answer choices to check. Because 2 is found in J and K and it is not found in F, G, and H. So all I'm going to do is just plug this whole thing. I'm just going to plug the left side in on the calculator and type in 2 for X and see, do I get +3? So I just go math, then I go to num, absolute value is the first option there, 1 minus 2 parentheses 2. Okay, I do get 3. So what does that mean? F is gone. G is gone. H is gone. It's got to be one of these two. And now you can check either one. It doesn't matter. I'll check -1 just because that is the first answer choice I come to. And again, to save time, I'm not going to retype the whole thing. I'm just going to copy the last line down on the calculator. And now I just need to second insert a negative sign and then change the 2 to a 1. Okay. Now go ahead, enter. Okay, +3. This one works. Correct answer is letter J. Okay, and we don't even need to bother checking K. We know that these two work. So again, with the technique of back solving here, I took the answer choices, I plugged one in, and basically I found that 3 of the answer choices didn't work, and 2 of them did. And then from there, I just checked the 2 remaining ones and found out which one was correct. But in conjunction with that, I also used the graphing calculator to do the arithmetic calculations in order to speed up the process as well. So I know that there's a lot of, again, a lot of talking going on and explanation for this problem, so it might not seem all that quick, but if you're actually sitting down, and you read this problem, and then you look at the answer choices, pick a number to check, go to the calculator, press math, go to num, select first option, type in 1 minus 2, parentheses, whatever number you chose, parentheses, enter. It's really not that long at all. And then cross out the ones that don't work, decide the other value you need to check, and, and keep going. Now, this is actually something that we've touched on a little bit, in the last couple of slides, but another way to save time on the math section of the ACT is to use a graphing calculator, or if you don't have a graphing calculator, if you have a scientific, I guess that's fine. Use your scientific calculator for all arithmetic calculations. Obviously, if there's a very basic thing that you can do in your head, like whatever, 5 squared, or the square root of 16 or whatever, you don't need to spend time punching that into the calculator. But anything that has multiple steps, you definitely want to type into the calculator and ideally just put it all, on one line, making sure that you use the appropriate parentheses, or other grouping symbols as needed. So let's take a look now at another example problem. This is from the April 2022 test, Form E25. It's problem number 9. So here you can see the problem on the screen. Again, this is an absolute value question. And all you have to do is, again, on the graphing calculator, again, I'm using a TI-84 plus C model, but you could easily do it on a TI-84 plus or TI-83 plus as well. So to get this answer, I'm just going to go to math, num, 1, type in -3. And obviously, you're not going to be talking these things out loud to yourself as you're doing it, so you can do it even quicker than I am, especially because you can just press it rather than me using the mouse. Okay, so now to solve this problem, all I'm going to do is just punch in the entire expression on the calculator using the absolute value functions. So we go to math, then to num, absolute value, -3, and you're going to see that it'll be even quicker than the method I'm doing it, because when you're doing it, obviously you're not talking to yourself, you're not explaining it to anyone, you're just punching it in, and also not clicking in with a mouse like I am. So just punching in all in one step, we get the correct answer. It looks like letter B, -39, and that's it. So just type the whole thing in the calculator, hit enter, get your answer, move on to the next question. Just be careful that you are entering everything incorrectly, including negative signs and, parentheses or other grouping symbols. But you want to do as many arithmetic calculations on the graphing calculator as possible. So now let's take a look at another example problem. This is from, again, April 2022 test. It's Form Z08, the international version. It's problem number 51. And you can see on the left side of the screen, basically the description and picture for it. And then on the right side of the screen is the actual problem itself. So here, they basically give you a formula, and you just have to plug in A and B to that formula, and they ask, what interval does that value come in with, fall between. So you do have to recognize that in the problem, they tell you the major axis is 16, and the minor axis is 12, and then in this formula, A and B are half the lengths of the major and minor axis. So you do have to recognize A is 8 and B is 6. But once you recognize that, then just go ahead and punch this whole thing into the graphing calculator. Don't try to do it by hand. So let me just move the calculator on the screen here so that there we can see the formula. So notice we just are going to do square root, and I'll put a parentheses, and then it's 8 squared minus 6 squared, and then close parentheses, divided by 8. 0.661, so that is between 0.6 and 0.8. So correct answer is just going to be letter D right there. And that's it. Takes you maybe 10 seconds, 12 seconds just to punch the whole thing into the calculator and get your answer. Don't worry about trying to do it by hand or in your head or anything. Just do any and all arithmetic calculations on the graphing calculator whenever possible. Now, another way that the graphing calculator can be useful is by doing operations on it. And so this could include many different types of things. So it could be, graphing something, finding an x-intercept or a zero of something, finding maximum minimum value of a function, something with complex numbers, which we're going to take a look at in a little bit. There are many operations built into, graphing calculators, or specifically a TI-84 plus model. And you want to use them whenever you can to solve problems either partly or completely on the test, again, because of the amount of time that can be saved in doing that. So now let's take a look at an example problem. It's from the April 2022 test. It is Form E25, and it's problem number 41. So there's the problem on the screen. It's basically asking for 3 plus I quantity squared. What does that equal? What does that simplify to? So if you were going to do this the traditional way, kind of by hand, you would have to write it out twice. And then you could go ahead and do FOIL, get your 4 terms, combine your like terms. You end up replacing I squared with -1. Then you combine some more like terms and get your final answer. However, we can do this entire problem on the calculator in virtually no time at all. First, we just want to double check and make sure that we are in A plus BI mode. So I go to the mode screen, and yes, we are. And then all I have to do is just type in 3 plus I. I get I down here by hitting second and period. Close the parentheses, squared button, 8 plus 6I. There's our answer. Letter C. That's it. if you're already in A plus BI mode, then typing that expression in on the calculator should take you less than 10 seconds. So there's like an extra 50 seconds right there that you can allot to other problems by just typing this one in on the calculator and doing it just like that. Now let's take a look at another problem. This is from, again, April 2022. It's from Form Z08, and it is problem number 8. It's asking for the least common multiple of 20 and 30 and 130. So if you're doing this by hand, or the way you'd probably be taught to do it in school, I mean, the most common way is you kind of take all the numbers and you break them down, into their prime factors. Well, that's just 5 and 1, but 2 and 2. And then we do the same thing with 30. And then we could do the same thing with 130. Okay, 2 and 5. And then you have to go through and you have to line up all the prime factors and things that overlap. You only have to list once, and but things that are listed multiple times in one number, like the two twos here, you have to make sure that there's 2 of those. But whatever. Okay. The point is, we don't need to do that. We can just do this on the calculator much quicker and much easier. So keep in mind, though, technically you can only do 2 numbers at a time, at least on this model graphing calculator. So we will have to do it twice, but it's really not going to be that much more time. So first thing I would go to the math menu. We go to num. We go to LCM. I'm going to put in now the first 2 numbers, 20, comma 30. All right, so I get 60. Now, the way I have to do it when I have a third number is I just have to find the LCM of that number and our third number. So I'll just copy down the last line. I'll replace this 2 with a 6, so I have 60, and then I'll just insert a 1 here. So now I have 130. Enter. Okay, 780. Final answer, letter J. And that's it. Again, total amount of time it took me to type that in the calculator, probably less than 30 seconds. I just go to the math menu, I go to num, I go to whatever it was, option 8, I think, and then I'm on the home screen, type in the 2 numbers with a comma, enter, copy the last line down, press a 6 over the 2, insert a 1 in front of the 3, enter, we have our answer. So again, that gives you more time you can use on other problems. Now, one last thing just to keep in mind. So being able to identify when to use these techniques or these specific calculator options, is something that you will need to practice on and work on. I mean, it's basically it's going to be almost as important as, learning the actual material for the test itself. So in other words, you need to, begin practicing when to recognize, okay, here's a problem where I can use backsolving or plugging in the answers. Or here's a problem where I can use the graphing calculator to solve the entire thing for me. So those are things you want to practice and work on, just like you are practicing and working on, learning whatever material it is that you are reviewing for the test. Basic things like, slope-intercept form of a line, or how to find the slope between 2 points, or how to, different trigonometric functions in a right triangle, all the stuff like that. Now, process of elimination and using the calculator for arithmetic operations, those are basically things that you want to do on every problem if possible. Obviously, process of elimination is not going to be able to be used on all 60 questions. And also, similarly with using a calculator, there's not going to be arithmetic calculations that you need to do on every single question, or some of them is going to be just really, really basic that you don't need to spend the time, typing the thing into it. But in general, you want to be in the habit of doing those on every problem that you can. So process of elimination should be a technique or a strategy, or really a way to think about how to answer a problem that you want to do, as much as possible is the point. So to summarize, basically kind of what this whole video is about, identifying when to use techniques, and or, a calculator, specifically a graphing calculator, and then applying them to the questions as you're working through practice tests and then when you're taking the official test is what is going to allow you to improve your timing and to answer more problems on the test. Basically, like practicing these skills and getting better and better at them and refining them is what's going to allow you to save time on the earlier questions, on the first 30 or 40 or 50 questions, and then you will have, and to give you time that's left over then to answer the last 10 or last 15 problems. So again, if you have any questions or comments or whatever about this video, please feel free to leave a comment below. Otherwise, like this video, subscribe to my channel, click the notification button so you find out whenever new videos are posted. And that's pretty much about it for this video on how to improve your timing on the math section of the ACT.